And I didn't look at the instructions, but I'm assuming it says to graph these things. Identify and sketch. Okay. So I gave you 6 quadric surfaces the other day. Which one does this look like? Looks like that. Yeah, it looks like that saddle shape, the hyperbolic paraboloid shape. If you don't realize that, you could look at 2 kinds of cross sections. Remember, when I say cross sections or trace, when I'm talking about the kinds of cross sections we look at, we're talking about the traces or cross sections created by cutting the surface with a plane that's either in or parallel to one of the coordinate planes. So either the xz plane, yz plane, xy plane, that sort of thing. So you can check, I mean, for sure that this is a hyperbolic paraboloid. If it's called a hyperbolic paraboloid, one of the traces, well, one kind of trace, there's billions of traces, right? But one kind of trace should be a paraboloid, and one kind of trace should be a hyperbola. Now, if it's a hyperbolic paraboloid, it's actually 2. So you look at the, so we'll identify it. We'll call it a hyperbolic paraboloid. Because it fits the description I gave you in the notes of a hyperbolic paraboloid. But if you did, here's what I'm trying to get across. If you didn't remember which one it is, like on a test or something, you can figure it out. If it's a hyperbolic paraboloid, the oidness indicates 2. Well, this is the connection I make. I don't know if it was meant to be this way. But if it's a paraboloid, then 2 kinds of traces will be parabolas. Okay? If it's a hyperbolic paraboloid, one of the kinds of traces will be a hyperbola. Does that make sense? So 2 traces are parabolas. And when I say 2 traces, I mean 2 kinds of traces. There's billions of traces, an infinite number of traces that are parabolas. And because it's hyperbolic in front, one kind of trace is a hyperbola. So working backwards, if you didn't know or you weren't sure if it were a hyperbolic paraboloid, you could look at this. For instance, if you let x equal, say, 0, which would knock out this entire term, you get a trace z equals y squared divided by 16, which will be in the yz plane. What kind of object is that? What kind of curve is that? A parabola. If you let, now it doesn't always work to let x or y equals 0, but x or y would equal a constant in various cases would be helpful. What if you let y, 0 works here as well. What if you let y equals 0? Then y squared over 16 is knocked out, and you get z is equal to negative x squared over 9, which is in the xz plane. That would be a trace in the xz plane. And what kind of object is that? So there's 2 kinds of traces that are parabolas. Now, what if you let z be a constant? If you let z, now you don't want to let z equal 0, but if you let z equal a constant like 1, it doesn't have to be 1, then you get like 1 equals y squared over 16 minus x squared over 9. That's a hyperbola, right? Okay. So it's got to be a hyperbolic paraboloid. Now, how do you draw these things? Well, you know, you draw it first, and you don't draw the traces like they show you in the book. That'll drive you nuts. You draw it first. I draw the same picture every time, and I adjust the axes appropriately. So I'm just going to draw the same picture I showed you last time and adjust the axes appropriately. So I know what a saddle looks like, or imagine a Pringles potato chip. Very similar thing. So I'm going to draw, the way I like to draw this is I'm going to start with 2 of the same kind of trace. There's going to be 2 parabolas that open downward, right? Parallel with the xz plane, we get parabolas that open down. So those are kind of 2 copies of parabolas that open down. And then there's going to be a parabola that opens up. The one I draw specifically is the one when, in this case, when x equals 0, and then you get z equals positive y squared over 16. And that it's pretty easy to show that that's going to go through the origin. So the parabola that opens up, the origin will be right around there. In the middle of that trace that's opening up. And then there'll be a trace. I'm going to think of z as being a negative number. It's easier to go down below 0, 0, 0 to picture this. A trace down here in a plane parallel with the xy plane where z equals a negative constant. You'll get parabolas that look, or not parabolas, but hyperbolas. One branch will open that way, and then the other branch will be a mirror image of that, like that. And then if you insist on putting in axes, you got to be careful to get that right. Let me show you the z-axis. We always have the positive z-axis going up. If you want to make part of that dotted where it's overlapping with the surface itself, you could just erase a tiny bit down here and then maybe draw it in, make it dashed right there. So that's the z-axis. Now you have to think about it. Okay, is the x-axis going to be in the plane of the screen, or should we draw it coming out at you? Well, look, if x were 0, then we've already determined you get z equals y squared over 16. And in fact, that would be this parabola opening up right here. Okay, because it's got to be in the yz plane. Okay, so then the way I've drawn this, it looks to me like we're going to want to have the y-axis in the screen, aren't we? Yeah. And so I just decide afterwards to put it in the screen. Let's see. So I'm going to make this the y-axis. It's a little bit tilted, but that's okay. So I'm going to make this the positive y-axis. And again, if you want, you could, where it's supposed to be underneath the surface, you could make the y-axis dashed. Does everybody see why it's going that way? Because in the yz plane, it should have that trace that goes up, that smiley face that goes up, z equals y squared over 16. Yeah.
So what values should we incorporate into this?
Well, hold on, I'm not done. So if we draw in the x-axis to keep the right-hand rule in play, I'm just going to draw the x-axis like that. Positive x-axis right there. As far as values here, it's not going to be a huge issue. You're not going to have to graph a whole lot of these. I mean, if you gave me or if I rather give you a y value here, then you should be able to come up with, I suppose, the relevant vertex of this trace, right? And the equation of that trace. For instance, I could make up a test question where we make that y value equal to, I don't care, 4, right? So let's suppose for the sake of argument, let's suppose I give you, I'm just making this up, I don't know if it's going to be a question or not. Suppose for the sake of argument that I tell you y equals 4, okay? You give me the equation of that trace. That's something you should be able to do. So what would, okay, wait, I've covered up my equation. So what would you do to come up with the equation? Now let me highlight it for you. The trace that I'm talking about when y equals 4 would be this parabola opening down, right? It keeps going, but I drew it so that it stops, so that it looked like, well, it looked like something familiar, like a saddle shape. When it really doesn't. In reality, it just keeps going out, and it only looks like a saddle shape near the origin. So if y were equal 4, what would the trace be? Well, I would, I would put the y in there, the y equals 4 in there, and at y equals 4, I could say z equals, well, 4 squared, which is, of course, 16, so 1 minus x squared over 9. Now, if I wanted to get if I wanted to get even more in depth, I could ask you, well, what is the vertex of that thing? And you'd have to be careful, realize that you're not actually, that trace in red is not actually in the XZ plane, right? It's in the plane given by y equals 4, which is a a vertical plane parallel to the XZ plane, isn't it? So if I asked you for that vertex in space, whoa, what would you say? So okay, if it were in the XZ plane, then I wouldn't advise writing this down, but if it were in the XZ plane, then you're kind of looking at this is the trace, and then you're thinking of this equation as, oh, sorry, that should be Z. Z-axis versus x-axis, and then the equation is Z equals 1 minus x squared. So you look at this thing and you realize right away that, okay, the x-coordinate of the vertex up here has to be what? 0. The z-coordinate has to be what? 1. Wait, z is actually on the very end. There's a coordinate in between. What's the y-coordinate? Technically it's 4. So you should be able to put little things like that together.